So in the afternoon assignment lecture, I'm gonna revisit like the topic of testing, continuing from the morning. Um, so yeah, as I say, like in this week we will talk about testing. We will see what type of tests are there and what kind of tests that we can or we should use. We should apply to our applications. So the topic of testing is part of the development life cycle of applications, as you know. So once we like gather requirements and then we design our application, then we start development. After that, we do testing, then we deploy our website, and then we can have like we can automate this the deployment process or it's called continuous integration, as we will talk next week, the week after the next week. But yeah, anyway, now we are in testing, and it is important. You can actually know the importance of testing when from your previous projects. Um, So when you write code for the first time, when you write a component, let's say a React component, it will work like because you wrote it, you saw the results, and you like it was working as expected. But the issue is when there is a team of people working on the same product, and they are all contributing to the software. And because of that, like the parts that was working, that were working before, might not be working once we do the integration from different sources. That's why like testing the components, testing our code all the time is extremely important. So in this week, we will learn like different types of tests. We will write those tests, and those are the most, let's say, like important and popular at the same time. So there's this graph which like categorize, you can say, types of software testing. Yeah, before I begin, like categorization or talking about software testing can be looked at from different perspectives. So if you try to search about this topic, you would find different like people categorizing this in different ways, and that's okay, that's normal. So it's the way we look at software testing. But yeah, anyway, this is one way to look at software testing, which is so our tests could be manual or could be automated. So they're the same tests. We can make them manually, or we can write scripts, and we can make like we can make them as a software, you can say. And this is what we are going to do this week. Manual testing basically is, let's say you have a software and you have a React application. There, it contains multiple components. So you can write a test in pseudocode, and you can bring a tester that would test you the application manually. So this is manual. But what we can do is write test, right? Like we can write software, we can write code that represent like real testers, and we can run that automatically. So this process, each of course has its pros and cons, but the automatic one is like it's less complex. It's also okay. Can you see my screen, or does it like? Okay, thank you. Yeah. Yeah, so we automate testing, we write code, and there's pros and cons for that. And we do that because, as I told you in the beginning, we need to run tests on each new integration to our code. It's cheaper, it's less complex than manual testing, but like manual testing is there's more confidence, let's say, in manual testing because we like there's a person who try to test our application. All right. Now we have three types of testing. This is from, you can say, technical point of view: white box, black box, and gray box. So in the morning, Tasneem was talking about types of testing, and that was a different categorization, which was more of from the application point of view. This is from a technical point of view, from testing point of view. So we don't like, I don't want to make this like difficult by having different categorization, but it's like it's good to look at testing from different perspectives. But at the end, like the ultimate goal of this week is to know about unit testing, integration, or system testing, and finally, integration and system testing. But what we will do, we will learn unit testing. We will do API testing, which could be under integration testing. And finally, we will do end-to-end testing, which is considered also system testing. So yeah, this is our goal. But it's also good to know the difference between what white box is, black box, and gray box. So black box testing is that we imagine you have a black box, you have input, you have output. So you assign input, and then you should expect output. So you don't care about the like what is happening inside the box. Rather, you care about the output, or let's say the test, not us, not we like care or not care, but the test itself doesn't care about like what is inside the box. It cares about what the input. Yeah, sorry, the input and the output. So let's say I have I want to test console log, for instance. So I write the test for console log. If I entered, let's say, hello world. So if, let's say, I have console world here, if I like run console world with hello world, I should have hello world printed on the console. So the test for console world should be that if I entered console log, the output should be that console log has been called with hello world. So this is a basic functional unit testing, basically. So this is the black box. White box is that the test is aware about the like the code, is aware about what is happening inside like the code. But yeah, we for now in this week we will do black box testing, and we will do functional, which is basically it's more concerned with the code and with the output. Those, for instance, related to performance, compatibility. Maybe this is related to having different modules working together. Performance, and we have usability testing, which is related to the user experience. So those are non-functional. Those are the functional. So we will learn about unit testing. We will see the difference between Sorry, is there a question? Okay, so we will learn about unit and integration testing. Usually integration testing is more complex or difficult than unit testing. So we will stick to unit testing, but since we have APIs, or we have like we connected to the database and we have a backend server. So we will learn about how we can test our endpoints. If you remember from last week, from the last 2 weeks. And finally, we will do system testing. Or before that, we will also do unit testing for React components. So unit testing, you can test any logic of any programming language. In our case, it's going to be JavaScript. So you can test any JavaScript logic. Then also you can test your React components. The difference is of course we have components rendered on the screen. So we need to find a way that we can test that. Yeah, so we will learn unit testing, API, React, and then finally we will do end-to-end testing. We will also use different tools for each. Yeah, we will use Jest here, Supertest for API, and Cypress for end-to-end. There's many tools out there, of course. Jest is yeah, as for Jest, it's probably the most popular in terms of unit testing for JavaScript. So this is, yeah, this article that I found helpful for today, which talks about unit testing, integration, and end-to-end, and give us also some code snippets. So we will talk about this in detail tomorrow. But yeah, for today, let's have a quick look about those. So unit tests, we basically test individual units. And when we say units here, it's basically units of code. So it could be functions, classes, or even like certain logic, certain block of code that you want to test. So for instance, this is a very short and quick test. We have a function and we want to test that function. So we pass a value and we expect the value to be 10. So when we run the test, if this, like if the function that we called gave us 10, then the test would pass. If it doesn't, it's gonna fail. And then we have to figure out how to solve our code. Now again, when when you write your code, you know it's working, because let's say you have a like a function that add two numbers, let's say 2 plus x plus y. The function takes two arguments and return the summation of these two arguments. So you can tell that, okay, I pass 2 and 3 and the result is 5. So this is in normal scenarios. In when you have like when you have simple scenarios, that's obvious. But when you have a function that is more complex and that contains more edge cases, let's say, this is what we focus when we are talking about unit testing. So that might be, yeah, here's the tricky part, let's say, appears. So now we test an isolated block of code. It's isolated from other parts of the code, and we need to test its edge cases. So for instance, in terms of the summation function, if like 0, if one of the arguments is 0, it's still safe, but it could be considered an edge case. 0 plus 5 is 5, so the result is going to be the second argument, let's say. But let's say maybe this is obvious in terms of a division function. So if you have a function that take x plus y, so again, we will talk about this in details tomorrow. but you can consider this as just a like a soft introduction to code in the context of testing. So yeah, I don't know what I'm using, why I'm using Miro, but so if we have a division, like a function that takes x and y, and it returns x over y. So if the second argument is 0, so this is considered an edge case. So if your function takes x and y, and you return x divided by y, then the result is going to be not a number, I guess. It's going to be none. And you might not be like noticing this because you wrote the function, and the cases that you have when you wrote the function was okay. Your numbers was, let's say, integers, and they were more than 10, let's say. So you just tried to write your function and it was working correctly, but you didn't consider edge cases. Here it comes the value of testing. So you write tests, you think about edge cases. Of course, this is an example. For a division, you think that, okay, dividing, there's a case where y could be 0. So you should say that if y is 0, then you should return none or something. So the test should be or when the test fails, you should like modify your code. So your code is going to be, if y is not 0, then do xy. But if y else, just return 0, for instance. So after your test fails, you do this. You basically like it's a bug, and you correct that bug. So yeah, again, we are basically writing code, and we think of edge cases, then we run these tests, and we match. There's matching, basically. We match our functions, our block of codes, with certain like expectations, and the result is either the test fail or pass. If it pass, then we are good, we are happy. But if it failed, then it's gonna tell us that the software, the tool, sorry, the testing tool is going to tell us that there is something wrong, there is an error, you should check here, it gave me here, so it wasn't as expected. It's going to tell you, the software is going to tell you that you expected to have this, but you received this instead. So you go back to your function and correct that. So as you can see, we have a place where we write this code. So we have our code in a place, we have our components, and then we have separate files where we add our tests. So we import our components or our functions into these files. This is usually the structure of testing. Again, we will talk about this tomorrow. Now, the second type is integration tests, which is basically testing several units and how they work together. So in unit tests, we isolate blocks of code, we isolate functions, we test them by themselves. But integration tests, we do the opposite. We try to combine, or we try to integrate units and test this integration. Does this integration works as expected, or do we have certain errors or side effects? For instance, we have here like a button. First, we select the button with the ID. We click the button. Of course, this is pseudocode, we click the button and then we expect that is drone flying command set. So basically, if the button is clicked for this drone, then this function should be called. So as you can see, we integrated the button with this function. Those are two components, or let's say two units of code. One is the button itself. The second is this function that should be called once we click. Now, of course, this is pseudocode, and this is very simple example, but usually integration tests are complex than unit tests. And actually, there's different like opinions. Should we like do unit tests more than integration tests, or the opposite? So it depends on the project, but usually unit tests are cheaper and less complex. So usually this is the like, yeah, I guess so. I guess that the first thing that like let's say a medium team would do, a medium development team would just start doing unit tests, writing those, and yeah, like integrate software, integrate their code with like with repo, with merging their main repo. Yeah, so this is unit testing, this is integration testing, and also finally here we have end-to-end tests, which is basically we test all the application from start to end. So for instance, here we have an app that take us to page that once we like once we run the application, it takes us to this local host with this port number, and then the user should type something. The user there is a login page. The user type username, password, clicks on login. Expect that we go to the dashboard, and then expect the name to be the test name. So again, this is pseudocode, and this is basically emulating a full interaction with the application. This comes last after the first the unit test and the integration tests, and yeah, in tests are more complex because we have to go like to cover all the application, and it's slower as well. So like unit tests are like the fastest, and tests are the slowest. So yeah, there's these metrics that we take into consideration as well when like deciding what tests should we write and execute. So we will execute our tests in Node.js, and we will use Jest. So Jest is a test runner, but in this article they did this like categorization, let's say, of test tools. There's test launchers, test providers, assertion functions. Those actually functionalities, let's say, of software tools. So they note or they list the functionality and list the software or the tool that provide that. But with Jest, we have launchers, we have structure providers, we have assertion functions. We will talk about that again tomorrow, and we can display summaries, we can do mocks, and we can, yeah, generate snapshots, and we can generate code coverage as well. And okay, this is with Cypress. And finally, yeah, we don't have visual regression tools. So we will yeah, with jest, we can do almost all those, and all that with a very um, lightweight, let's say, lightweight tool called Jest. It's used for JavaScript, and it's one of the most popular frameworks out there. Um, so any questions so far about testing? Even from the morning, how did you find the topic? Or are you familiar with testing? Yes, so the tests we all right. So yes, exactly. With we can do, so we will do unit tests with Jest, and with for end-to-end testing we will use Cypress. Um, yeah, like system testing, part of system testing is end-to-end tests, which we will use Cypress. And for API test, okay, before that, API tests super test. So the code is like for Jest, super test, and we have also React testing library. So I know there's many libraries, but the code is like is going to be integrated, let's say. So when you test JavaScript, you use only Jest. When you do when you want to test React, then you can use we will use Jest beside testing library, this library. And when we want to test APIs, we will use Jest in addition to Supertest. So okay, great to hear, Novita. But yeah, I think you have like you got the concept, let's say, of how we the purpose of testing, or the like the conceptual idea of like we have code, let's say here we have function, and we have function takes x and y, and then it return x over y, but we have a separate file, and the file contains um, code as well, and we will import the function, and then we will test this function with code as well, but with different new concepts, let's say. But mainly we will do something like in pseudocode, we should like expect the calling of let's say 2 over 2, 2, 2, basically x and y are 2, expect this to be 1. So like this is the high level view of testing, which is you have a code, you have a logic, you have a certain logic. So you test that with this like line of code. Again, this is pseudocode, and this is a very simple example. It doesn't necessarily to be one line of code, but the idea is we call the function and we say expect the result to be something. Or basically we do matching. One of these matchers are to be. So with that, we can know if there is like issue with our code by testing different edge cases. So like as Novita mentioned, this is concerned with quality assurance. We want to make sure that our code is like we should have high confidence that our code should work in most circumstances. So that's why we write tests. And in big projects, in big like companies, they have even a life cycle for tests alone. Like for software in general, there is life cycle. I think like many of you heard of Agile, for instance. So there is set of practices when a team like when a team wants to develop a software, they follow a set of practices, or they call it sometimes a like software life cycle, something like this. So yeah, for the software, it starts from gathering requirements, design, as we have done in the course, briefly, of course, for requirements, design, and then we focused on code most of the time. We do development, then the next step is to do testing, and after that, deployment and moving to production or moving the code to production. Similarly, in big projects, in big apps, there is life cycle just for testing as well. And it consists of like gathering requirements, but for testing, for the tests, think of what code to test, think of edge cases, and so on. And then after that, execute these tests, read the results, fix the errors, and so on. But yeah, now we are focusing about the principles, about especially unit tests, about the concepts. It's very important to know how what is happening here. Even in job postings, sometimes you would find that they are asking if you're familiar with testing. Like, are you familiar with? Sometimes they mention just actually. Like I think so. Is just is like React. So React is very popular in terms of front-end development. In terms of JavaScript testing, just is also one of the most popular frameworks. So you would find that, do you have like knowledge of Jest, or do you know Jest, or are you familiar with software testing? So yeah, this is what we will do this week. We will be familiar with testing, what is the basics, how we can test our code, our Node.js, our Node servers, and we will also test React application as well, and see the difference between testing only Node or testing only JavaScript beside testing React. We will test APIs, and we will learn like different concepts that make this process easier. And finally, we will do the Cypress. We will do the end-to-end testing with Cypress. Yeah. Okay. Okay, I think we can stop for today.